Okay, welcome dear learners, and this is normal move out. What does normal move out mean? Well, normal move out, this is the difference in travel time due to the difference in the source to geophone distance that happens due to the reflection on the horizontal interface. Remember the expression for the travel time of the seismic waves to any geophone, to the geophone at any distance, let's say the distance x. This is given as x over v squared plus 2h plus 2h over v squared, which is also x over v squared plus t naught squared. This is tx squared, of course, squared. You can try to factorize t naught squared outside. T naught squared will be it will be the same as t naught squared is outside of the bracket 1 times 1 plus x over v squared over times 1 over t naught squared. So tx squared is given this way. If you apply the square root each side, you get tx is equal to t naught 1 plus x over v squared t naught then raised by a half. If you expand this beautiful, attractive expression, if you expand this term binomial, then you will get t naught 1 raised by a half plus a half down. Then this is 1 raised by negative a half. Then x over v t naught squared. Then plus a half. Then negative a half over 2 factorial. Then you multiply by x over v t naught. Then raised by 4. Thanks. tx will now be the same as t naught times 1 plus a half x over v t naught squared minus 1 over 8 x over v t naught raised by 4. Okay, for this expression, if we consider that when x over vt naught, which is exactly, of course, the same as x over 2h, is very, very small compared to 1. And what does this condition hold? This condition hold when the depth to the interface is very large compared to the source to geophone separation. And therefore, the condition for x over 2h being less than 1, this holds for the interface at a great depth. And therefore, if this condition hold, then we can neglect the third term in our expansion here because it will be very, very small. We can neglect this third term in the other higher powers so that this can be expressed by 2 terms. And therefore, tx, total travel time at any distance x, will be given as t naught times 1 plus a half. Now let's look to that expression exactly. Times x over v t naught, then squared. Of course, yes. If you open the brackets, then you will have tx will be the same as T naught plus a half x squared over T naught v squared. If you find the expression for t when x is equal to 0, will be t naught is the same as t naught. If you substitute here x is equal to 0, then you will have t naught. And therefore, the normal move out will be given as tx minus t naught, which will of course be a half x squared over t naught v squared. This will be the expression for the normal move out. This is the expression. But remember, this expression works correctly at the grid depth when the interface is at a very, very large depth. But what about for shallow depth interface? If the interface is at a shallow depth, then the condition of x over 2h to be less than 1 will not hold, and therefore this formula, if it will be used to find the total the normal or move out, it will not work accurately, but it will involve errors. But what do? The simple solution is to include the third term. So if we include the third term, the expression for the tx will be given as this one here. And if we find the normal move out, then we take this tx, we minus t naught, which is the same as this term minus t naught, then t naught here, and we shall finally get the simple expression of this, that will be tx minus t naught, which is the normal move out, will be given as normal move out will be equals to x squared over 2t naught v squared minus x raised by 4 over 8t naught 3v raised by 4. This is now the expression for the normal move out at a shallow depth, and it works also at a great depth, but for a shallow depth can work accurately compared to this simple expression. Thanks for watching.